Welcome to In 5 Minutes. Let us draw a few conclusions from the FM frequency spectrum that we have just now discussed. We have already discussed one conclusion, which is that the theoretical bandwidth of FM is infinite. Now, even though we had done it for FM signal and we are going to write down few conclusions based on that, please remember that this conclusions also apply to PM signal, which is phase modulation. So even in case of PM signal, its theoretical bandwidth will come out to be infinite. That means there will be infinite sidebands. Now, as we had already discussed, I cannot transmit a signal with infinite bandwidth, so I'll have to somehow restrict the bandwidth to a finite value, which can be done by transmitting finite number of sidebands. So please remember that we always transmit finite number of sidebands. That is because, as we said, as you go away from the carrier frequency towards the higher sidebands on both the sides, then the amplitude of those sidebands or those frequency components will keep on reducing. That means the power content of those sidebands will also reduce. In simple words, it means that the amount of information which they are going to carry will also reduce. So the major power content will be there in the first few sidebands around the carrier frequency, and hence that's the major information which the sidebands will be carrying. So now we will only keep the finite number of sidebands. The question is how to decide which sidebands, how many sidebands we have to keep. So we may use a simple thumb rule saying that only transmit those many number of sidebands which contain the maximum amount of power. Now when I say maximum amount of power, it could be from 95 to 98% of power. So let's say as a thumb rule, we conclude that as long as I'm able to transmit, let's say 98% of the power, I'm happily transmitting my signal. I'm able to transmit almost entire information. The sidebands which I'm going to not transmit, or the sidebands which I'm going to remove before the transmission, will only contain, let's say, 2% of the power or 5% of the power, not more than that, and hence loss of information will not be very large. With 98% of power, the reproduction on the receiver side will result in nearly perfect reproduced signal. Alright, so in that case, we are also not compromising with the quality of the signal. Please remember that there was no such issue in case of double sideband full carrier signal or any AM signal, because all the AM signals have finite bandwidths in their original form only. So we never require to truncate a part of frequency spectrum in order to finite the bandwidth. But then please do not jump to a conclusion that FM quality will not be as good as AM just because of a loss of small power or small amount of information which is taking place right now. We will discuss the quality of FM and we'll compare it with the AM, and we will prove that FM is superior to AM when it comes to the quality of reproduced signal in a noisy environment. So let us quickly now discuss what should be the bandwidth. Any FM signal which is transmitted to make sure that we are transmitting maximum amount of power, its bandwidth must be decided by something called as Carson's rule. So it is a simple relationship. Now we know how much power we want to transmit. Every sideband has a well-defined amplitude which comes from the mathematical expression. So I can calculate the amount of power which is there in the first set of sidebands, in the second set of sidebands, in the third set, and so on. So based on that, I can find out how many number of sidebands I require so as to transmit 95 to 98% of power. In the previous video clip, we have seen that one sideband will contribute to the bandwidth of FM. So if let's say if I come up with some numbers, say let's say 10 sidebands are required in specific case, then the bandwidth will be 10 FM. Now that 10 is obviously a specific example. In general, if I tell you the bandwidth FM, small FM is the bandwidth of the modulating signal, and let's say the modulation index used for FM is mu f. In that case, based on these two values, I can decide how many sidebands I need to transmit and what will be the total bandwidth.